For the last section of Chapter 1, we are going to do an introduction to parent functions. And a parent function is the simplest function with the defining characteristics of the family. So there are 5 different families of functions listed here in this chart. And the parent function is the most basic version you can get of each type of function. So the first one is a constant, and constant is just a whole number. So looking at that graph, it looks like that red line might be up 1 or 2. So the rule would be f of x equals 2. So c is just 2, and it's a straight line across the y-axis through 2. The domain is all real numbers. The range is whatever the c value is. So if in this case it's 2, then our range is 2. And then it intersects the y-axis at 0, and then the y value is whatever the c value is in that equation. Moving over to linear, the parent function is f of x equals x. It's just going to be a straight line. It's going to go through the point 0, 0, so that's going to be its y-intercept. Its domain and range are all real numbers, so it goes on forever in both directions. And then sliding over one more, we have quadratics. That parent function is f of x equals x squared, and that is a parabola. And it'll have a U shape, and the parent parabola is shown there in that picture. And the domain is all real numbers. The range is anything greater than 0 or equal to 0, and it goes through the y-axis at 0, 0 as well. The fourth one over is cubic, and that is f of x equals x to the 3rd power, and it's going to kind of give us that squiggle line there. Its domain and range are all real numbers as well, and it also goes through the y-axis at the point 0, 0. And then our last one is a square root function, and the most basic square root function we can have is just the square root of x. And it is starting at the point 0, 0 and extending in the first quadrant. Our domain and our range are both greater than or equal to 0, so everything's positive in that parent function. So for example 1, it says identify the parent function for g from its function rule. Then graph g on your calculator and describe what transformation of the parent function it represents. So I have x plus 5 here. So if I go back and look, the only type of function that just has an x without an exponent or anything else is linear. So the parent function here, it says identify the parent function. The parent function would be f of x equals x. That's the linear parent function. Now graph this on our calculator and describe what transformation of the parent function it represents. So if I move over here, I'm going to type in on Desmo's graphing calculator, I'm going to type in y equals x. And that's going to give us our parent function. And then for the second graph, I'm going to do our y equals x plus 5. And that gives us the function that they gave us in the example. So the red is the parent function, the blue is our new function. So what happened here? Well, if I look at the point 0, 0, right here, I can see that it slid up 5 units. And that is true with every point. So if I go over here, this point, if I go up 5, I still land on that blue line. So this is a translation up 5. And for the g of x equals the quantity of x minus 3 squared, if I go back to this parent function chart, the only one with a squared with an exponent of 2 is a quadratic. So I can identify this as a quadratic function. And the parent function is f of x equals x squared. So if I go over here, I'm going to clear out these. I'm going to enter in x squared here, so to the second power, so we can see our parent function. And then I'm going to enter the given function of y equals x plus 3 to the second power. So looking at our origin here, 0, 0, this point on our parent function, it looks like we have slid over 3 to the left. So that's true for every point here. So this is the left side of the parent function here. If I slide over 3 units, I'm right over here. And we can zoom in so everything is labeled there. Oh, everything is labeled. So again, here, this outside, if I slide over 3, I'm on the edge of our new quadratic function there. So what happened to this one? It slid to the left 3. It was a translation 3. Okay. Example 2 says graph the data from the table. Describe the parent function and the transformation that best approximates the data set. So I'm going to pause and I'm going to graph these ordered pairs real quick. So after plotting these points, it appears that this is a quadratic function. And the parent function then would be f of x equals x squared. If I quickly make a t-table of some ordered pairs from that, if x was -2, I would have -2 squared would be 4. If x was 0, 0 squared would be 0. And if x was 2, 2 squared would be 4. So comparing those to these 3 points, that's our parent function. And if I were to graph them, I would go over -2, up 4, 0, 0, and over 2, up 4. It appears that our parent function is just a little bit smaller or compressed than our function that was given. Our parent function was, an ordered pair was -2, 4, and this original graph given was -2, 2. So it looks like it's cut in half, and our factor is a half, so our compression, oops, with a factor of 1/2. And that was a vertical compression. I guess we need to clarify that as well. All right, so for example 3, an oceanographer wants to determine a model that can be used to estimate wind speed based upon wave height. Graph the relationship from the wave height to the wind speed and identify which parent function best describes it. Then use the graph to estimate the wave height when the wind speed is 10 knots. So the first numbers given in our chart are wave height. So those are our x's, and the wind speed would be our y's. So this is wave, and the y is the wind. So if I try to plot these the best I can, because they are decimals, over 2 up 8.8 would be about there. 4, 12.4, going to be up here. So looking at this graph and our y values, they're not going to fit on here. So what I am going to do is actually change the y-axis and what it's counting by. So I'm going to make it go by 2s instead and see if that gives us enough room. All right, so over 2 up 8.8. 4 is 12.4. 6 is 15.2. 8 is 17.5. And 10 is 19.6. So if you look, it's kind of given us an arc over here. And if we go back to our chart, that really looks like the square root function. So they wanted to know the parent function that describes this. So that would be the square root of, so the f of x equals the square root of x is our parent. And then use the graph to estimate the wave height when the wind speed is 10 knots. So the wind is our y value, and we're going to take that at 10 across over here to see where we meet that graph. And our wave height would be approximately 2.5 according to this graph. So I'm going to say about 2.5 feet is what that was, the unit was there.